All right, so GM everybody, I'm Yusuf and I'm your host for the Glassy Hours. So if it's your first time here, Glassy Hours are a bi-weekly series or online session in which we cover any topic around Solana development. And today we got Nico, and he is the co-founder of Elusiv. And if you didn't already hear about it, they just launched on mainnet, and Nico is going to show us today on how we can use the Elusiv SDK to build private dApps with, secret transactions. And so, yeah, I'm just gonna hand it over to Nico and have fun.
Perfect. Yeah, thanks so much, Yusuf. Before I get started, this is what I look like, just so you have a face to match instead of the purple monkey. Let me just share my screen real quick. Here we go. All right. Yeah, so like Yusuf said, small correction, we didn't launch on mainnet, but we did that already 3 months ago, but we launched our SDK on mainnet, which is what I'll be talking about today. For some of you who might not know what Elusiv is, Elusiv is a privacy protocol on Solana, just 30-second rundown, which basically, like Yusuf said, it gives you the ability to privately interact with accounts without everyone being able to see, in your favorite block explorer, exactly what you're up to, who you're sending money to, who you're receiving money from, and so on. I'm sure as many of you know, like the core technology behind this is zero-knowledge proofs. However, those can be obviously a bit difficult to get into, and especially using the Solana is not super straightforward. So that's why we built this nice little SDK that should hopefully make it very easy to use that and integrate that into your dApp that you're building. That's what I'll show you today. And so for those of you, if you want to follow along, our SDK can be installed on npm just at elusiv/SDK. The samples, the code I'll be going over today in a second, can be found at Elusiv privacy/Elusiv samples on GitHub, open source. So yeah, if you want to follow along with the code while I demonstrate, feel free to do so. And finally, later on, if you want to read more about the Elusiv SDK, we have docs here, docs.elusiv.io. There you have all the explanations of how Elusiv works in depth, and of course, the documentation for the SDK itself. So what we'll be doing today is a couple of different things. So for one, I'll be showing you the main flow of it, but to make it a bit more interesting, I'll also show you an example app, super simple, of how we could use it together with Solana Pay. So that's what we'll be going over today. In case you guys have any questions at any point, feel free to just unmute yourself and tell them to me. You don't have to wait till the end or anything like that. If you could not write it in chat though, that would be helpful, because for some reason when I'm sharing screen, I don't know why, but my Zoom is kind of messed up. I can't see chat messages, so it would be helpful if you could say it then, or if someone could read them out in case there are questions. So the main idea of Elusiv is basically it gives you the ability to create something called a private balance. And what a private balance is, you can sort of imagine it similar to the balance that you have on a normal Solana account, which basically tells you how much SOL you have or how much USDC or what have you, and then you can send or do other things from your public balance. Private balance is the same thing, except that if I take your public key and I type it into the block explorer, I can see what your public balance is, who else you're sending money to. The difference with a private balance, as it implies, is that there's no way anyone can see what that is except for yourself. And that's basically the core functionality of Elusiv. Now, if you want to integrate that into your dApp, the core part of the Elusiv SDK, it can be found inside, this little code chunk here. So here we have this little get params method, which I wrote myself just for this demo, which just gives back some useful things that you often need in Solana programs. So one is a key pair. Pretty sure most of you are familiar with that, which just a private public key, oftentimes in the form of a wallet. Another one is a connection to the Solana RPC. And the last one is, the one that's a bit more special, is the Elusiv instance. Now, how do we create or how do we get this Elusiv instance? So if we look at this code real quick, first thing we do is we create a new connection. Okay, nice. Not that special. Second thing we do is we get our key pair. Okay, not that special either. Usually you often do this through a wallet adapter. And this part is a little bit more interesting. This is what's a bit different to conventional Solana programs. So here what we're actually doing is to generate the elusive instance. We need a couple of parameters: connection, what cluster we're operating on, and our public key, all standard parameters, and this parameter called a seed. And essentially this seed is what's actually used under the hood to generate the cryptographic parameters that are then used to do all the cryptography to make sure that your balance stays private on chain. So this is generally something you don't want to log in the console or send to your friend or something like that. You can think of it sort of as a little bit weaker version of a private key. So yeah, you don't want to necessarily be spouting this out in the world and telling everyone about it. And the way you generate it is rather straightforward. You just do a signature over E25519, so just standard Solana signature of this thing called seed message. And this is a constant that's exported by the Elusiv SDK, so you don't have to define this yourself. And yeah, you just sign this thing. The signature that you get out, you can then use as a seed. And once you have that, you're basically good to go. You've created the elusive instance. So yeah, okay, we've created our elusive instance. Cool, but more interestingly, how can we actually use this thing? So the first operation that you can do in Elusiv is called top-up. And the idea of top-up, I think, as the name sort of implies already. The point of it is basically you have some SOL in or some other token in your public balance, and now you want to make it private. And you do that using this top-up operation. And the way you build a top-up transaction for Elusiv is pretty similar how you build most transactions for Elusiv, in fact. There's basically consists of two main steps. Step one is we say, okay, const top-up transaction equals elusive instance, which is that thing we created before. Let me turn this off real quick, which is that, class we created before. And we say build top-up transaction. And then we say, how much do we want to top up with? Which, we just take in here. Then we say, what token type do we want to top up with? You can see there in the little preview, we have a couple token types supported. And are adding more as we go. So in this case, we pass that in as well. And then finally, we say, these last parameters aren't really relevant in most cases. So for the sake of this tutorial, I'm going to leave them out. So first thing we did is we create our top-up transaction. Okay, nice. Now, remember, since this is a transaction where we're converting from public balance to private balance, the way you prove that you own money, or the way transactions work in public balances or in normal Solana, basically, is that you need to always sign them to essentially prove, oh, this is my key pair. I'm allowed to make a transaction from it. So in this case, we still need to sign it. So we have to do top-up transaction dot transaction dot partial sign. We pass in our key pair, and finally we just do elusive dot send elusive transaction with our top-up transaction that's been signed. So if we look at the top-up function, basically two main steps: build your top-up transaction and say how much it should be and what token type, and second, send it off. And we have this little wrapper code here to actually call it, which, as we can see, it's going to send 1 billion LAN ports, which is basically one SOL. So let's try running this and see what happens. So if we do npm run top-up, which is just going to execute the script, we'll see it should log. Exactly, it's saying initiating top-up. And then something we'll notice here is, unfortunately, this takes a little bit longer than your conventional super fast Solana transactions that you might be used to. This is also linked to the reason why some of you who have worked with Solana before might be a little bit surprised that why are we sending off the transaction using this elusive instance rather than a connection object like we usually do. And the reason for this is because to perform the cryptography, to perform such a top-up, under the hood, we actually can't do that in one transaction because we run out of compute budget. So basically we don't have, we run out of compute budget. So what this elusive instance send elusive transaction actually does for you is it takes care of essentially completing all 24 transactions that are needed to perform a top-up. So under the hood, it needs 24 transactions for now. Unfortunately, we're working hard to optimize it. But using the send elusive transaction method, you hopefully shouldn't notice too much of it. Aside from it taking 20 seconds instead of 2 seconds or even less. But we can now see, okay, top up complete with signature, blah, 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 blah. If we paste this into the block explorer, we can quickly have a look at how this looks. .NET. And yeah, basically what we should be seeing here is a bunch of different stuff that's maybe not that relevant, but most importantly, okay, we can see this is the key I'm using for this demo, deposited 1 SOL. So yeah, as expected, we sent 1 SOL away, and hopefully it should be added to our private balance. So yeah, now we have a private balance, not bad, but of course, not that interesting yet either, because more interestingly is when we can actually access our private balance and perform a send from there, which is what we're going to do next. But yeah, before I do that, any questions so far about the top up, or any comment or anything that was a bit unclear so far? Okay, if not, I'll take that as a no. Perfect. Then let's move on to the next part, which is sending. So like I said, what we just did is we put, I think we put 1 SOL into our private balance. So now what we want to do is, first, we want to check what our current private balance is to see if that 1 SOL actually arrived. And second, we want to try sending it to someone. So yeah, the way we get our private balance, pretty straightforward as well. We just say private balance equals await elusive dot get latest private balance. And then we say what token type we want it for, in this case, Lamports, because that's what we just topped it up for. Yeah, then here we should log in the console and we should hopefully see 1 billion. And next, what we want to do is we want to send half a SOL to ourselves. Okay, doesn't make much sense, but in this case, yeah, let's just do it for the sake of demonstration. So yeah, how do we do such a send? So if we look at the top up, step 1 was build top up transaction, okay, and step 2 was send elusive transaction. So pretty much the same idea for send. We say step 1 is send transaction equals awaits.elusive.build send transactions. Then we say how much we want to send, the recipient that should receive it, and the token type, and a bunch of other parameters. But yeah, for basic send, you don't really need to pay attention to those. And yeah, and what we do now is we say elusive.send elusive transaction, send transaction. Now, if we compare these two, actually, let me start running this one as well. We say npm run send, should hopefully log our private balance and send half a SOL privately to, you know what? Let me make this a random key pair, actually, because then we can see it more clearly. Okay. So yeah, this should hopefully send half a SOL to a random key after logging our private balance. Exactly. So yeah, private balance, I think that's 1 billion, or I hope at least. Yeah, seems to be. And yeah, while that runs, unfortunately, similar to the top up, this takes 63 transactions to verify. Let's quickly compare these two. So if we put the top up here, we can see basically, the first step is the same. Okay, build the transaction type that we want to build. The last step is the same, use send elusive transaction using elusive, but the middle step for the send here is missing. Whereas here for the top up, we sign it, but on the send, we don't do that. Now, does anyone have an idea why that might be? Why we don't have the signing thing for when we do the send, the private send?
Because anyone can receive Lamport in Solana.
Sorry, can you repeat that?
You can send Solana to anyone.
Yeah, that's true.
Yeah.
Is it that otherwise there's a signature attached to the private transaction, which reveals
exactly. That's actually exactly, that's the correct answer. Because here, if we would sign it, as the name signature implies, anyone can then see, oh, this private transaction was from our public key, which would be, pretty useless. Because then we would take all these extra steps with the top up and the send, and then in the end, on the block explorer, you could just see, oh, the signature implies it came from our original public key. It wouldn't have gained any privacy. However, what this actually does under the hood is it sends it via a relayer, which actually takes care of the signing for us, and proves ownership of the private funds using a zero-knowledge proof. And that's why, if we look at this send transaction here in the block explorer, now remember our old key from before is AEJUK. Now, if we look at the send transaction that we just did, and I do a command F for AEJUK or AEJ, in this case, we can see nowhere in the transaction accounts is our key even mentioned. No signature, no reference key, no nothing. So essentially, through this, our random recipient that just received the funds, he can see, okay, I received half my SOL, should say here, exactly. So this guy, 4WX, he just received half the SOL that we want to send him. But again, if he looks here in the associated addresses or the accounts that are associated with this transaction, there's nowhere that he can see that what my public key AEJ is. So basically, I have full privacy with regards to this guy. He doesn't know what my public key is, and therefore he can't trace what I'm doing on chain, which is pretty cool in my opinion. So yeah, this is and that's already the basic flow. So if you want to do private transfers in your Solana dApp, you can do it with 1, 2, 3, 4, or this is the same line. So 3.5 lines of code. So hopefully it shouldn't be too complicated to implement. But yeah, that's the basic flow. And now after this, let's move on to something a little bit more interesting, which is using it with Solana Pay. But yeah, before I do that, one more time, does anyone have any questions about anything so far, or anything unclear or comments? Yeah.
I was actually just wondering if you like the destination and the source when you're topping up. I assume it all would it goes into some kind of a centralized pool where it can't be proved that afterwards you can send it back out of it again, and the whatever private balance you have, essentially somehow you guys can prove that account shall it be, or your existing keeper has a private balance without revealing the balance itself. Is there a way to sort to let's say if that pool is it one centralized pool for everybody? Is it like one? So the more technically the more volume you guys have, the more obfuscated everything is.
That's correct. Yeah.
Okay, cool. So if let's say hypothetically I was the only user, it wouldn't actually work because you could, if I send it in and then I send it out again, you could see what I was doing.
That's correct. Yeah, exactly. You would be, if you were the only user, you would be protected in a cryptographic sense, because no one could fully prove using the exact transactions on chain that it was you. But in a practical sense, obviously you wouldn't gain much privacy, because then what people would see is, oh, so you topped up 10 SOL and someone sent out 5 SOL, but obviously since you're the only person that would have topped up, you wouldn't have gained any privacy in that sense. So yeah, that's correct. That's the main system that this operates under.
Super cool.
Yeah. Any other questions at this point?
Yeah, one question. Can you elaborate in terms of audits that you guys had? Because that centralized pool makes a pretty neat honeypot in itself, obviously.
Yeah, absolutely. Yeah, in terms of audits, we have had 2 audits so far. We have had our circuits. So for those of you who are a little bit more into zero-knowledge proofs, the way you define zero-knowledge proofs is using something called arithmetic circuits, which are just very small programs that define how your zero-knowledge proof is supposed to operate. So the zero-knowledge proofs we've had audited by ABDK. ABDK is an auditing firm founded by the guy who invented the Poseidon hash. Again, for those of you who are a bit into cryptography, you might know Poseidon hash is probably the most popular hashing function that exists for zero-knowledge proofs. So that's for the circuits and for the smart contract itself. So that's what contains the shared pool, basically. We had that audited by OtterSec so far, or OSEC for short. They're pretty active on Solana, so some of you might have heard of them before. Yeah.
Awesome, thanks. Kudos.
Yeah, thanks. Yeah, any other questions at this point? No? All right. In that case, let's move on to the next part. So I think most of you probably have already heard about Solana Pay, but just as a refresher, let me just give a quick overview about what Solana, if I can click this, but what Solana Pay actually is and how it works. So yeah, as most of you probably already know, Solana Pay is a protocol developed by Solana Labs itself, which essentially allows you to universally encode so-called transaction or transfer requests, which are, as the name implies, ways to encode all the information needed to request a transfer of funds or a more generic transaction from someone else inside of a URL or a QR code. So yeah, for the sake of this demo, we'll be doing transfer requests because those are a little bit simpler. The difference between a transfer and transaction request is a transfer request says, hey, please send me this much money, whereas a transaction request, as the name implies, says, hey, please execute this transaction, and then I'll do something for you. So yeah, for transfer request, let's quickly have a look at the parameters, just so we're familiar with them. So the first one, recipient, I think pretty obvious. It's just who should receive the funds of that transfer request. Amount, I think self-explanatory as well. How much should be sent? SPL token, also pretty straightforward. Basically, what should be sent. Reference key, I think this is the most important one of this and is not as straightforward. The idea of this is basically it's a special key or a set of keys that are attached to said transfer transaction. And the reason that this is needed is, let's say you are, I don't know, Amazon.com or some store that, has a bunch of volume, sells a bunch of things. And let's say you and me are both currently customers of Amazon and we want to use Solana Pay to pay for something. And, we're both buying a soccer ball, for example, and it costs $30 for both of us. And so Amazon says, okay, please send 30 USDC to this address. And once you've done that, I'll send you your soccer ball. Now let's assume you and me, we basically send our 30 USDC almost at the same time, or rather one of us sends the 30 USDC. How would Amazon then know, wait, did the 30 USDC come from Nico or did they come from you? Who do I send the soccer ball to and who hasn't paid yet? That's the point of the reference key. The reference key basically says, hey, by the way, you should send this much money of this type to me, and you should attach the special key unique to you. So that way I know that when, the funds arrive with this reference key, I know that I gave you that reference key, and that's how I know that that money came from you. And that's the idea of that, which is quite useful for Elusiv as well, as we'll see in a second. Next, label. This is not relevant for the transaction itself. This is just what's displayed in the UI often, which is usually what good is being sold. Actually, no, what store is selling the good, I meant. So in our example, it'd be Amazon. Message is what good is being sold, so a soccer ball in this case. And memo, as some of you might know, allows you to attach a small message to your transaction. And yeah, redirect isn't relevant for the case of this example. So yeah, let's see how we can combine this with Elusiv. So yeah, again, to give you the basic scenario of what we're trying to do here, the idea is we have a merchant that's trying to sell us, some product. We, as the customer, we want to pay for the product, but we don't want the merchant, to be able to track us on chain and see what our public key is and our balances and who else we're interacting with and all that. So we want to pay our merchant with Elusiv, but our merchant has never heard of Elusiv, so we want to do this in a portable way. So yeah, the first thing we have to do is just generate a couple of parameters that the merchant is going to use. You can say, okay, so first we need a recipient that our merchant wants to receive the money at. So for that, since it's just an example, let's just make this some random public key. We also need a reference key. So for that, we can also say, oops, we're going to generate some random key. I'll generate a public key. Yeah, for the memo, let's add a memo as well. Why not? That needs to be encoded in URI, if I recall correctly. Let's say our #1 Elusiv transfer. Yeah, and finally for the amount, let's say whatever we're buying costs 0.1 0.1 SOL, which, since if I recall correctly, we still have 0.5 SOL in our balance, we should have plenty to pay for that. So yeah, that's that. So next, what we need to do is we need to create our Solana Pay request. So again, the request, the idea here is we're the merchant. We have all this information, but we want to tell to our customer, hey, this is the recipient you should send to, this is the amount you should send to, but we want to transfer it to him inside of a URL or a QR code. So for this, we encode it in, the Solana Pay standardized request that we just looked at a second ago. So to do that, there's a create request function, which I didn't invent. This is from the Solana Pay SDK. So if you guys want to use Solana Pay, yeah, it has a bunch of cool functions for making it easy to work with. So we just fill all our parameters in there. Label in this case, what did we say? Amazon is not that great. Let's say the Solana mobile. Actually, no, let's say Solana Spaces. Throw it back to them. And for the item that we're buying, the Elusiv cap classic. In case you guys don't have it yet, check out the Berlin Hacker House or so. Then you can probably pick it up, or any other hacker house. Okay, so yeah, and we add our memo as well. Then what we want to do next is we want to parse our parameters from it, which is basically, you can imagine, let's write this here to make it a bit more clear, customer code. So basically this stuff up here, so from here until here is what our merchant does. So he generates his Solana Pay request. Now here you can imagine he shows us a QR code or redirects us to a link or something like that. And now this is what we, as the customer, we have to do. So yeah, yeah, so let's get rid of this. So what we want to do next is we want to build a send transaction to be able to pay for our elusive cap. So we can say send transaction, like we said before, is elusive.build send transaction. And now we can use all these other parameters that are inside of this function, inside of this huge parameter list. So as usual, amount, or actually, sorry, params dot amount in LAMP ports, params dot their recipient, token type was LAMP ports in this case, reference key params dot reference, memo params dot memo, and yeah, this other stuff. So okay, we don't need that right now. So yeah, basically what we're doing now is we're encoding a Solana Pay transaction inside of a private elusive transfer. And yeah, now we build a private transfer, and what we're going to do is we're going to send that off. So let's say bounce result equals elusive dot send elusive transaction. Okay. Before I continue, looking at this line of code, does anyone notice anything that might be wrong with that? Or if we would just run it like this, why might something unexpected happen? Does anyone have an idea? No? Okay, in that case, maybe I can drop a little hint, which I will do by hovering on this and have a look at the return type. Does anyone have an idea, looking at the return type, what might be wrong here?
We didn't sign a transaction yet.
That's true. However, the signing, remember, is only necessary for top-ups. For sending, we don't need to sign it because it's private. But good idea.
It's from this,
my bad.
so
Yeah, I don't know, wait.
That's correct.
yeah, I know.
So exactly. So yeah, but remember, this is a trick question actually. Here we're still the customer, right? And so if we're the customer and we would just await for it, and then we'd tell the merchant, here, look on my phone, I awaited for my elusive transaction to complete, blah, blah, blah. Look, I sent it to you. The merchant might not trust you. He might say, no, but I didn't receive it with the correct reference key like I wanted, blah, blah, blah. So here what we're going to do actually is we're going to purposefully not await it. And instead, we're going to use standard Solana Pay methods and have the merchant actually try to wait for it. because what Solana Pay offers is it offers something called, oops, that's caps lock. Solana Pay offers something called await Solana Pay confirmation, which is what a merchant can actually use using that reference key, which we called ref and a connection. And what this basically means is here our merchant is using a method from the Solana Pay SDK. So again, our merchant has no idea that Elusiv even exists. For him, he's just expecting a normal Solana transaction. So yeah, let's see if that works in that case. npm run Solana Pay, I think I called this. Yeah, which should first create a request, encode it in a private Elusiv send transaction, send it off without actually waiting for it, and then having our merchant try to receive it. So yeah, let's give this a second and see what happens. And yeah, just to reiterate, or actually to maybe give a bit of hope for those of you a little worried about it being slow or something like that at the moment. The cool thing is the Solana Foundation actually will implement Groth 16, which is the essentially the zero-knowledge proof system that we use, syscalls soon, which means this will all be possible in one transaction once those syscalls are on mainnet live. But yeah, for now, unfortunately, you have to bear with us. It takes 60-ish transactions. Okay. So yeah, here we can see checking for transactions 1. Let's see what that means inside of here. There we go. Okay. Now, I don't know why it took that long this time, but at least, better soon than never. Our merchant, as expected, he created, again, from the point of view of our merchant, he created a standard Solana Pay transfer request, which, by default expects just a standard Solana transfer. And, he awaited a standard Solana Pay transfer without doing anything with Elusiv. All the Elusiv stuff was done by us, the customer. And at the end, he was still able to detect it. So everyone's happy. We as the customer, we're happy because we got to keep our privacy and still got to pay according to the Solana Pay spec. And our merchant, he's happy too, because he didn't have to think about, oh, now I have to integrate this Elusiv tool to be able to detect Elusiv transactions or something like that. He's still able to work with his normal existing Solana Pay code without having to change anything. And it just works out of the box. So yeah, that's pretty cool in my opinion. Yeah, before I move on, any questions about this so far or about anything before?
Yeah, so quick question. Is there any additional fees for using, let's say, you said that the transactions that are sent to a relayer. So is there any additional cost associated with that?
Yeah, so 2 things about that. So first, at the moment, the only additional cost associated with that is that instead of paying the transaction fee for one transaction, like I mentioned before, unfortunately, sending a private transaction at the moment under the hood means you're actually doing 60 transactions. So that means the additional fees are basically, having to pay 60 times 5,000 lamp ports instead of 1 times 5,000 lamp ports, which is a bit annoying. On top of that, however, we don't charge at the moment any additional relayer fees or something like that. That's basically just the transaction fees. And if at any moment, of course, before you send off your transaction or something like that, you want to check out how much does my transaction, what are the transaction fees? You can do send transaction dot here, get total fee amount. That'll return your number in the token type of the current transaction. So in this case, if we would run this, it would tell us performing the send transaction is going to cost so and so many lamp ports. However, if we would do this with USDC, get total fee amount would tell us it will cost us so and so much USDC. That's another thing about Elusiv, to avoid needing to top up lamp ports and USDC to your private balance just to pay for transaction fees. You can always pay for transaction fees directly in the actual token that's inside your private balance. So yeah, it's usually around 60 transactions, so 60 times 5,000 lamp ports. which is 300,000 line ports, if I can do math, or the equivalent in the current USDC price, or whichever token you're sending from. But yeah, to get the exact amount, you can always use this get total fee amount method.
Hey,
Yep.
quick question.
Yeah.
I think when you did the elusiv.buildsendTX, I think there was a param which was like, is
This one?
Solana Pay? I think it was there,
no,
yeah.
build, yes.
I think there was there a param that was like, is Solana Pay transaction or something?
That's correct.
Okay, I was just wondering like what that's for and why we didn't need to use it here.
Absolutely. So the reason for that is that like you saw here, we have the reference key. And the reason we're not using it is because at least in most cases we can think of, there might be some cases where you don't need the reference key. Where you're using a reference key but not doing a Solana Pay transaction. However, by default, what essentially happens here is it checks, okay, did I get a reference key? If I got a reference key, by default, I'll set Solana Pay transaction to true. And basically this allows you to say, no, I want to add a reference key, but I don't want it to be a Solana Pay transaction, so you can set this to false.
Got you. Okay, cool.
Yeah, that's the idea.
Neat.
Quick question, actually, probably pretty granular, but I've had some experience with you trying to do cryptography in the VM and running out of compute because it's all really expensive. How do you guys split? How do you like split up? How do you split transactions like that? Like if you wanted to do one, you're doing like one continuous calculation, obviously. How do you like segment that?
Yes, the way you segment it. So basically what's interesting, what's actually quite good and why we decided, okay, there's a bit into the details, but why we decided on using Gross16 specifically for our zero-knowledge proof verification algorithm is that the steps for it are constant, basically. So it consists of three main parts. The first part is slightly different depending on small factors, but for the most part, it's the same. And the final two steps are always the exact same, no matter what your proof encodes, which is very useful because that means we have basically constant verification time. And since we know that these are always the same constant steps, what we can do, and they're always applied to the same essentially initial amount of data, which just keeps getting transformed. What we can do is we can, when we do our first send elusive transaction with a zero-knowledge proof, is we, under the hood, we can temporarily rent an account. We dump all our data into there. And then we basically have, a network of relayers that constantly check, oh, is any, is any one of these sub accounts currently containing data? If yes, just crank these transactions through and that basically perform the proof verification. And the useful thing is, like I said, since it's always the same steps, they don't actually have to look at the data and make sure, okay, how do I need to send this transaction? They can just say, oh, okay, data is still there. That means I can send another transaction and get refunded for it. And just keep doing that until you're finally done. I hope that answered your question or not.
Super cool.
Cool. Yeah, and if you're interested in like the exact nitty-gritty details on our GitHub, we have the smart contract code for this open source. So there you can see the exact details of how it works if you're interested in that. Yeah.
Thanks.
Cool. Any other questions at this point?
No. There's one more question in the chat. Does the Groth16 implementation into Solana mean I don't have to top up my private balance anymore, or will I be able to top up balance plus send transfer in 1TX?
Yeah, so that's two questions. So the first one is, unfortunately, the topping up step, you'll always have in pretty much every privacy protocol I can think of, because most privacy protocols, as I mentioned earlier, rely on the same idea that Elusiv does, which is you have a centralized pool with a bunch of different funds. You do a top up into that centralized pool, or just to be clear, centralized in this case means multiple people send to it. Not Elusiv controls it, it's part of a smart contract. But yeah, you have this pool, you send your funds into there with a top up, and then essentially you privately sending means you send from that pool and an outside observer doesn't know which top up did it. So you'll always have, or at least for the foreseeable future, you'll always have that top up and send step. However, the advantage of the Groth16 syscalls being native in Solana is what I just described previously with the whole, putting the data in accounts, needing to crank through transactions to verify it and so on. The reason we need to do that is, as the person who asked the question, whose name unfortunately couldn't see, correctly pointed out, is that the Solana VM isn't optimized at the moment for this type of operation, which means we need to do multiple transactions to be able to do such a big computation because it doesn't fit in one transaction. Which is also why, as you see when I demonstrate here, it takes like, 30, 40 seconds for a transaction to actually go through. Whereas, as you're probably used to, is if you would do a normal Solana send, it takes like 1 second or 2 seconds. And the advantage of these syscalls is basically that there's a native way to do this proof verification step, which basically means that the sending the elusive transaction step, you'd be able to do that in one transaction, which means it would be, way faster, like 60 times faster, literally. Instead of 60 transactions, it would take one. Similar logic can be applied, this takes a bit more in-depth explanation, but it also means that the top-up transaction fits in 1 or 2 transactions. So the main advantage of that Ground 16 syscall thing is just it makes it way, 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 way faster, as fast as a normal Solana transaction.
Actually, a new question concerning that as well. Are you guys, so I'm kind of on a similar path of hopefully making a PR soon that will enable different cryptography, so basically a different elliptic curve on chain. And we do a native program or a syscall as well. Are you guys writing it yourself, or is Labs taking over on that part?
The Ground 16, you mean?
Yeah.
The Ground 16 was actually written by, I believe it was Labs already. Like this has already been written, like I think end of last year. What we're basically just waiting at this point is for them to actually deploy it on mainnet.
Okay, for the feature to okay.
Exactly, we're waiting for the feature to be deployed. But yeah, you can, it's not on DevNet and testnet yet either. However, what you can do if you want to experiment with it yourself is you can basically run your own local cluster and try it out there. But yeah, unfortunately at the moment it's not on DevNet or on mainnet yet.
Okay. Do you guys have any like an estimate as to how at what Solana version it probably will get on there? Like I'm assuming like
or something
like that.
1.16 I believe it was. Yeah, and that should come out within like 2 months, we're hoping. But I mean, I'm not on the core Solana team, so I can't tell you the exact of that. So yeah, take my word with a grain of salt for the exact time frame of this. But yeah, the sooner the better.
I've been told the exact same things where things like this can be written quite quickly, but actually merging it and getting the feature activated is like the longest wait.
Yeah, that's correct, unfortunately.
Super cool. Thanks, though.
Yeah, no worries. Cool. Any other questions about this right now? Okay, excellent. In that case, we have a few minutes left. And I have one more small thing I can show you guys, which I think is pretty cool too. Is for those of you who might be a bit more into, who might have used different privacy protocols in the past or are interested in on-chain privacy in general, you probably have already heard that like a bit of a touchy subject regarding this is always, compliance and all that stuff. So for that reason, with our SDK, we also offer some ways that you or your users who use your app can easily essentially, demonstrate compliance. So it means they can use this, remain anonymous on chain, but still reveal to certain parties what their private transactions are. That sounds very theoretical. So let me show you a quick example of this as well. So the main idea is, as we saw before, when we looked in the Block Explorer, which I closed now, when we looked in the Block Explorer, there was no way to see what my initial public key was. But however, when you're doing your taxes, or if for whatever other reason you want to show your friend or someone else, you want to prove to them, hey, no, this transaction on chain is private. But here I want to prove to you that this transaction actually came from me. This is the public key behind it. For this, you can use something called a viewing key. The way you generate that is by doing get viewing key, I think it was. No, wait. It was, one moment, let me double check this. It was, right. It was elusiv.get viewing key And then basically what you provide here is you provide the send transaction you want to get the viewing key for, which in this case we call last send transaction. And then we get back, a viewing key for the specific transaction. And then what we can do is we can take this viewing key and we can, give it to our friend. And our friend can basically use it to decrypt our on-chain transaction. So we can say const decrypted transaction equals await decrypt something viewing key, get send transaction with viewing key. There we go. With the connection, the cluster that we're on, in this case DevNet, and the viewing key. Here we go. Yeah, you might notice here how our friend has to use a normal function. It's not part of this elusive superclass. Reason for that is obviously the only way he can generate this elusive superclass is if he would know our seed. However, with our seed, we can basically decrypt everything already. So this is a way to give our friend access to viewing one specific transaction without obviously giving him access to all of our private assets and letting him see and change everything. But yeah, let's log this as well. Decrypted transaction. Okay. What did I call this? I think viewing key. PM run viewing key. Exactly. And yeah, the advantage of this is here we can see it already. So we can see these are all, so this is from our Solana Pay transaction just now. Most of these parameters, if we would check in the block explorer, we could see them as well, just maybe not as nicely parsed, because we'd be able to see the amount, we'd be able to see the memo as well, signature and slot, obviously, the token type as well. However, what we wouldn't be able to see, what we're able to see in this case, is the owner. That's the special thing with this viewing key. If we think back to before, AEJUK, whatever, was indeed our public key. And what we saw here is we were able to generate this viewing key, give it to our friend, and our friend, without knowing our public key or without knowing our seed and therefore our elusive instance, he's still able to decrypt that specific transaction. So yeah, this is essentially a granular way to give someone access to one specific send transaction. Little Q&A. Does anyone have an idea why, if we look here at the get viewing key function, it says here in the parameter name, it says send transaction. Does anyone have an idea why it says send transaction and doesn't give you the option to generate a viewing key for a top-up transaction? No? Okay. Not that I can.
Isn't the top-up transaction already signed by you anyway? So it would just be, you could see that, you could see in the top-up transaction who topped up, right? So the owner is already publicly viewable.
That's exactly correct. There's exactly, as you said, there would be no point in generating a viewing key for that because our friend could just go to the block explorer and he could publicly see, oh yeah, this is the public key that did this, as opposed to the send transaction where, he can't see this, which is why he needs this viewing key.
Question for the encryption. So evidently you guys are somehow storing or encrypting the actual owner of send transaction in some kind of data, or I assume it's on chain, and then the viewing key with your seeds or your private key essentially creates a decryption key for that data.
That's exactly.
Yeah,
that's exactly correct.
Okay.
Viewing key generates a per transaction decryption key / encryption key, which is used to encrypt the original owner into the transaction data of that specific send transaction. And using the viewing key, we're able to decrypt what it is.
Okay, super cool. Is it just regular like asymmetric cryptography to create the encryption decryption keys?
So symmetric to be exact. It's just AES 256. Yeah.
Oh, super cool. And then okay, nice.
Yeah, exactly. And then you just have the key to perform the encryption with. When we generate our send transaction, we encrypt it. And when we do this is the key that was used, and we give it to our friend, and he just performs the decryption. Yeah.
Oh, super cool. Okay.
That's the main idea.
Nice.
Cool. Okay. So in this case, you have to tell me, Yusuf. I have like one more thing I could show, which takes like 5 minutes. Or if we're out of time, then we can just leave it at this as well.
I mean, if it's just 5 minutes, I would just say go ahead. Looks like people are interested.
For sure.
So, yeah.
Okay, yeah. Perfect. Think of sort of the super viewing key, whereas the viewing key, you give it to your friend and he can see one specific transaction, but he can't see your private balance or what other transactions you have. Root viewing key is basically essentially allows someone to see everything of your private account. So you have to be very careful with this, but this might be useful in some cases as well. So basically, the way you generate, oops, okay, well, I mean, there you go. We already had the code, so let me just not write it by hand so we can go quickly. Main idea is we say, okay, get root viewing key from our Elusiv instance. Then we have this root viewing key. We give it to our friend or someone else. And then our friend, he can do get Elusiv viewer instance. So he can create a so-called Elusiv viewer. And as the name implies, the difference between an Elusiv instance and an Elusiv viewer is with an Elusiv instance. If we do Elusiv dot, we can see it has a bunch of different stuff like building transactions, sending transactions, and so on. With the viewer, however, we do dots, we can see it only has 2 things you can do with it. You can get the current private balance of the root viewing key owner, and you can get all private transactions, which is still very powerful because it lets you see everything. So yeah, what we're doing here, just quickly in the code, is we're generating a viewing key. We generate an Elusiv viewer, and then here, just a couple of times, we say we get our balance from the viewer, and yeah, okay, basically we get our transactions from Elusiv and then from our viewer, and then we compare if those are the same. Let's just see how that looks. Let me check what this was called. Here, root viewing. Yeah, and in case someone's interested as well, how this works under the hood. Yeah, we can see here this is the generate viewing key. Well, okay. Yeah, we can see here with Elusiv viewer, we were able to parse what our current private balance is, which is 0.399 Sol, which makes sense because first we sent 0.5 Sol, and then after that we sent 0.1 Sol plus fees, basically leaves us at almost 0.4 Sol. So that means, yeah, if we look what we got with the normal Elusiv instance and what we got with the Elusiv viewer, it returns the same value. So yeah, again, root viewing key you can think of as a global viewing key, basically allows someone to see, basically track your private accounts. So be very careful with this. But of course, still maintain your on-chain privacy. So yeah, basically a super viewing key. Cool. Yeah, no, that's, yeah, go on.
That as well. Sorry for hammering you with questions, but
no.
How are you, if it's symmetric encryption, how are you, like, how can you generate a transaction specific viewing key isn't a global viewing key if they depend on, I assume, what is like the seeds of your Elusiv instance, right? Somehow.
Yeah, exactly. So yeah, so multiple things. Under the hood, we essentially maintain a sort of counter for how many private transactions we've already done. And so yeah, if we're talking about the cryptography, we take the seed from that. We essentially, yeah, we derive. So yeah, so for spending, we need certain cryptographic parameters. Those we derive directly from the seed. However, the encryption keys to allow you to view past transactions. For that, we derive an in-between sort of, which is the essentially for each specific transaction, we take the index sort of that transaction and use HKDF, which stands for sorry, what am I talking about? Hash-based key derivation function. So basically, it's a function to derive more keys from existing key material together with salt. And feed in the root viewing key and the index of that current transaction, which gives us a brand new key, and we then use that new key for that specific transaction. And when we give someone else a root viewing key, they can then take this and basically derive each of the viewing keys for each transaction, and through that view all of your transactions. If that was able to follow, yeah.
That's super wicked.
Cool.
Okay,
Perfect.
thanks.
Awesome. Yeah, in that case, yeah, I hope it was interesting for you guys. And again, if you guys are interested, you can check it out on npm. Just install it like any other npm package, npmi at elusive SDK. For the docs, it's just docs.elusive.io. And yeah, if you have any questions or anything you want to discuss, even after this, feel free to text me on Telegram, especially. Let me drop my Telegram in the chat if I can figure out how to okay. Yeah. Yusuf, can you type in the chat real quick for me?
Yeah, sure.
Yeah. Can you type Sol Vitalik, which is my Telegram name? Bit silly. But yeah. Yeah, feel free to hit me up there, or we have a Discord server. You guys can ask questions in there as well. If there's any ideas or anything you would like. And yeah, that's pretty much it. Yeah, feel free to ask away if any of you have any more questions at this point about the SDK or Elusive in general, even.
Awesome. All right then. Thank you, Nico. I think it was a really great presentation. We all learned a lot of things. Yeah, so I also posted the links to all the socials and the Elusive website and the Elusive newsletter and all that into the chat. I don't know, do you guys have like job listings or anything? If that's the case, you can also post that into the chat.
Thank you for reminding me, actually. I almost forgot that we have a super team bounty at the moment, I believe. I think you can win like $1,000, something like that, for if you build something cool with the Elusive SDK. So yeah, feel free to check that out as well. Yeah, I don't have the exact link of that off the top of my head, unfortunately. But yeah, trust me, we have one.
Yeah, so just check out earn.superteam.fun, and there are all the bounties. And actually, I just got the bounty. I can just send it into the chat.
Thank you.
But yeah, so build an MVP with the Elusive SDK. Awesome. Yeah, so if there are no other questions or anything likewise, then I would just say thank you, Nico, and I'm sure we'll see each other at one point again. And yeah.
Yeah, for sure. Thanks so much for having me. And yeah, thanks all you guys for listening.
See you all at Hacker House,
All
hopefully.
Yeah, thanks for the presentation.
Exactly. Yeah, see you guys at the Hacker House soon. All right. Bye-bye, guys. Have a good day.
Bye.